This is SAT Practice Test 10 from the Bluebook, and it's the last one. After this, every single Bluebook test is on this channel, all perfect 800s. 70 minutes on the clock. I'm going to do it in about half that time and walk you through every shortcut along the way. I built a tool to practice exactly this kind of thing. I'll show you that in the middle. Let's go. All right, number one, here we go. For a particular machine that produces beads, 29 out of 100 it produces have a defect. What's the probability of selecting one with a defect? So basic probability, I mean, that doesn't really need an explanation, but probability is always a fraction. It's kind of favorable over our total. We have a total of 100 beads. In this case, the 29 are defective, so 29 out of 100, pretty basic. Next one over here gives an equation, S equals 40 plus 3t. It gives us the speed, S in miles per hour, of a certain car t seconds after it began. That's really important, right? They're always going to give you variables and they'll tell you what the variables are. S speed, t seconds, and you see the question is, what's the speed at 5 seconds? So all you do is just plug in 5 for t, right? And we get 55. You do that mentally as well. Next one, 4x equals 3. What's 24x? The shortcut to this is just, you can see that you can multiply 4x by 6 to make it 24x. So you just multiply both sides of the equation by 6 and you get this. Otherwise, remember, that's an equation. You could just put it in Desmos. That's what x is, right? And so if I know what x is, 0.75, I would multiply that by 24 that way. So a couple ways. Next one, scatter plot. Okay, line of best fit. This is a regression problem, right? Just open up Desmos, add your table, take 2 points from the line. It doesn't matter which two you use. You can kind of estimate this. It's not really going to be, one's going to be close, one's going to be not that close. You don't actually even need it here. You can see that this is a y-intercept of about 3, so positive 3, so not B or D. And then it has positive slope, so not C, right? But again, just to show you the regression tool, because you can use this later on. If I estimate a couple of points, right? So if I take like this point here, it could be like 0, and it could be 3.5, and then another point over here might be, it looks like 12 and 15, right? This button will appear here at the top left, right? Add regression, hit that, and you get your equation. So we can see it's about like 1x plus 3.5, so that's what A is. So again, here, just thinking about positive or negative slope and positive negative y-intercept, you could get it, but that's how you can do it as well. Next one, out of 300,000 paper clips, 234,000 are size large. What percent are large? It's just a fraction, right? Just do your 234,000 over 300,000, right? And we get 0.78, so 78%. Next one, here's another regression one, right? So that's why I brought it up. Typically, you can use that multiple times per test. They like this question. You put in 2 points. You don't need to put in all 3, just 2, right? So if I put in the first 2 points, smash my regression button, here's my equation, negative 5x plus 18, right? Freebie, if you kind of just spot that you need a linear equation. If you got 2 points, just do the regression, right? Next one here, another Desmos one. Just type in your function, f of x, and then just type in f of 2. And that's your answer. Easy. Next one. You could kind of do this in Desmos in a way. It's just more complicated than it needs to be. You should know your exponent rules, right? So like here, you're multiplying these. You got to add your exponents. M to the 4th times M is going to be M to the 5th, right? So you see, just literally multiplying the M's together. I know it has to be this, but the other ones you see Q to the 4, Q to the 5, add 4 and 5, that's Q to the 9, and negative 1 and positive 3 for Z is 2. So you should know that, but there's a way. If you watch the other videos about equivalent, or maybe we'll see another one in Desmos where I do show you equivalent using Desmos, but here, honestly, probably don't need it. Next one, triangle ABC is similar to triangle XYZ, right? So similar is something we want to know, right? Similar figures, they like that. 3 properties you want to know for similar figures. Number 1, corresponding angles are equal. So if you look at this picture, angle A, angle D are the same, angle B, angle E are the same, right? They got to have the same angle measures. Number 2, corresponding sides are proportional, right? So what that means is like some triangle is sometimes bigger or smaller than another. In this example, we can see over here 15 is 3 times bigger than 5, right? And then the last one is about trig ratios. If they happen to ask you about trig and they talk about angle A and angle D, they'll have the same trig ratios. So over here, let's see what we need. They tell us they're similar. AB is 170 and BC is 850. That will let us determine the proportion. So that's what we're going to do, right? So you could do 850 divided by 170. And you can see that the stuff here in this triangle, right, is 5 times bigger than this corresponding side over here, right? So you got to just pay attention to the letters, right? AB, that's the first two, that's the smaller one, and BC, the last two, that's the bigger one. So over here, they tell us about YZ, right? So that's the bigger one again, right? Because that's the final one, and we want to know about XY. So what you want to do is you want to divide it by 5, not multiply by 5, right? They don't have that answer choice, even if you were going to make that mistake, so I'm surprised. Usually they'll have that as a trap answer, but that's just 12 here. Next one, XY equals 4, and 24X over NY equals 4. Okay. Basically, this one, if you kind of like separate it, you can kind of see like it'd be 24N times X over Y, right? This is the same thing, equals 4. So what do you know? You know that this is 4, right? So it's basically, you know, this equation. So you can simplify this by multiplying or dividing by 4 on both sides. It doesn't matter. If you divide up 4 on both sides, you just get 24 over N equals 1. And so you get N is 24, right? So you can solve it kind of algebraically like that. Another thing you could do is this. You could just think of numbers of X and Y that equal 4, right? So like I can say X equals like 8, Y equals 2, for instance, right? And then in this one, right, where I have 24 times X over N times Y, right, equals 4, I could plug those in, 8 and 2, right? And then if I wanted Desmos to solve for X, I can just change N to be X, so Desmos solves for it, and you see here's our answer, and it's 24, just like we had over there. So a couple ways you could do that. Next one gives us an equation, linear equation, right? You want to notice when they're linear, right? Sometimes it tells you, but otherwise you want to notice it, right? So linear equation has no exponents, that's it. And it tells us the function W models the liquid in milliliters in a container T seconds after it begins draining from a hole at the bottom. Okay, what is the predicted volume in milliliters draining from the container each second? The whole key to this question is you reading this last part and understanding what they're asking you for. Because this is a linear equation, this question is asking you about slope. All right, here it is, right? In this linear equation, right, we got slope and y-intercept. Just be careful, slope is always the number that's attached to your variable, right? So it's the -4 here. B, the y-intercept is just the constant, the one without a variable, right? Sometimes they'll write it in like reverse order to try and trick you, right? But anyways, you see over here, if I know slope, slope tells me how something is increasing or decreasing, right? Draining is implying the decrease, right? And then the other thing was these two keywords I think are the most important thing, per and each. You see each second. I know that that's talking about slope just from that, literally that one word, right? Next one here, we got a graph here of f of x, right? And it basically just says for how many values of x does f of x equal 0, right? What you got to understand is really just that last part. What does that mean, right? So what it means is they're asking you to count how many x-intercepts you have, right? How do I know that's saying x-intercepts, right? Well, you see it says f of x equals 0. Over here it said y equals f of x, right? So it's telling you y is 0, right? And when y is 0, that's your x-intercepts, right? So there's going to be 1, 2, 3 x-intercepts, right? Just got to know that notation, just telling you to count the x-intercepts. Next one, this is an exponential equation, right? We were talking about our equation, so you got to know that here's our exponential equation. It really has two parts as well, just like this number in front, you want to know is the y-intercept, the initial value, that's the 3,000. And then this number in here tells you about the increase or decrease, and it's in terms of a percent, right? So this question here at the end, it just says, which is the best interpretation of 3,000, right? That's our y-intercept, right? We think about the y-intercept as the starting point. So it's not about the decrease, right? Not about the decrease, right? That's this number in here, right? The 0.75. And not the population after 8 years, it's the initial population, right? We literally kind of have that written there, right? Initial value, right? So knowing your keywords important. Next one gives us an equation. This is a quadratic equation, right? There's 3 equations basically that they use: linear, exponential, quadratic, right? They'll throw in some weird stuff from time to time, but that's far and few between. It's just those 3. So here's our quadratic. For a quadratic, you can always click on the minimum or maximum. Here it is. Just be careful you answer the right thing, right? You see here it says for what value of x does y reach its minimum? They want the x, so that's 7. When they want the y, it'll just say for what's the minimum value of the function or something like that. But when they want x, they'll explicitly state it like that, right? Simple. Next one, square A has side lengths that are 166 times the side lengths of square B. The area of square A is k times the area of square B. So this is your classic proportionality question. You see, here's an example with two rectangles. Let's say over here, this rectangle has sides 2 and 5. The area would be 10. Let's say we triple the sides, so there's 6 and 15. The area is 90. So you see, if you triple the sides, the area doesn't get tripled, right? What happened to the area? It actually was 9 times bigger. Why is that? So you want to know this proportionality. If your sides are 3 times bigger, then your area is going to be 9 times bigger. Why? Where does the 9 come from? Well, it's just 3 squared. Why squared? Area is units squared, right? And same thing for volume. You might see that from some time to time in a hard question. Volume is units cubed, right? So if it was talking about volume, volume would be 3 cubed bigger, right? So this question is just asking how many times bigger will it be? Well, it's just the 166 squared, right? So that's your answer. If you know that, really simple problem, really quick to solve. Next one, system, right? Put this in Desmos. You just got to change A and B to be X and Y, right? But that's it. So we got that one. We got this next one. Just change it to X and Y. Zoom in. Just be careful. Sometimes if you're too zoomed out, you might click on the wrong point. That's the Y-intercept, not their intersection. Here it is, right? So they want to know the B, which is Y for us. So that's 25. Next one gives us a function. It's an exponential function. It wants to know what's the Y-intercept. Simple, just put this into Desmos and you can click on it, right? You just want to know x-intercepts, maximum, minimums, y-intercepts, right? Those are all things we could just kind of click on if we put the function in. Sorry, just make sure you type it in. Just typed it in wrong as I was talking at the same time. Here's our graph, right? You see, you can always click on y-intercepts. It's 14. Next one, two variables, x and y, are related in such a way that an increase of 1 in the value of x, the value of y increases by a factor of 4. When x is 0, y is 200, which equation represents the situation? They gave you two facts that can help you like figure this out. The simplest fact is this one. Like they're literally telling you if you plug in 0 for x, it's going to give you 200. You can try this, right? So you see if I put in, you know, the first one and I put in 0 for the x there, right? That equals 0. So that doesn't equal 200. So it's not A, right? You can literally do this for all of them, right? And that's what we're going to do. This one here, you see, I put this in and I put in 0 and I get 4. I don't get 200, right? Next one, if I put in y equals 200 and then 0 to the 4th, that's going to be 0 as well. So that's not it. So it's D, but let's confirm. You see 200, 4 to the 0, right? The other way you could know this is, yeah, it's describing an exponential situation, and the 4 is going to be the, you know, base coefficient, right? Because a factor of 4. If they said like doubles, you'd see a 2 in there. If they said triples, you'd see a 3, right? They could have said quadruples, but they say by a factor of 4. Okay, next one. Simple, throw this into Desmos, right? You can literally type this into Desmos, sine 42 pi. The only thing that could go wrong is this might be in degrees rather than radians. Desmos is in radians by default. The way you change that is up here in this like tool wrench here. You click it, you see, and I can go between radians and degrees. So you see, if I was in degrees by mistake, I'd get the wrong answer. And that might happen if you're using like your handheld calculator. So over there, just make sure you're in the right mode as well. Otherwise, just, yeah, put that in. There will be questions with degrees, so you will have to change it. And if you don't, you'll probably get it wrong just because Desmos is in radian mode by default, right? Next one, another system. And it says, in the given system, H is a constant. If the system has no solutions, what is H? Okay, so no solutions. You want to just know this, right? What does this mean? It means that they're just like parallel lines, right? So you can do this on a graph. You can just put these into Desmos and you can just try these answers for H and just see like when they'll be parallel. That's why, yeah, this question is actually usually not multiple choice, because if it was multiple choice, it would be ridiculously simple like this every time, right? You see, I can just try -9, that's not parallel. I can try 0, that's not parallel. I can try 9, that's not parallel. Finally, I try 18 and you see that's when they're parallel. So that's why this question is actually usually free response and it's a little trickier, but here that's simple. Next one, quadratic equation, and it says one solution can be written as 1 plus square root k. Keyword here is solution, right? If you see the word solution, you can just type your equation into Desmos and it'll show you the solution, right? So here, if I zoom out, here are my two solutions. I can click on it. Now it's saying one of the solutions is 1 plus square root k, and k is one of these choices. So you literally just got to type this into Desmos, 1 plus square root 8. We can see that one first. Is that one of the solutions? No. So it's not 8, right? Then I change it to simply 10. Is that one of our solutions? I believe it was. Yeah, there it is, right? So it's 10. Really simple. Next one here. This is also not too bad, but it is a tricky one if you haven't seen these kind of problems before. So We have a few variations of this kind of question and other examples on Sigma Prep. So if you want to practice more of this, just go over there. And that's all it is, right? Like if you've kind of seen a question like this, you know what to do, right? And if you haven't, well, you're probably not going to get it right. Anyways, here, I just typed this in. You see, if I type this in, it's not going to give me the solution, but that's the question. We just talked about that. If it says solutions, Desmos will give you the solutions. You got to understand here why you're not getting solutions, why you're getting this error. And that's simply because Desmos doesn't know what C is. So in this case, you should tell it what C is, right? Like it says C is a positive constant, which means a positive number. I can just tell it like C is 6, for instance, right? And then you see, I can see my solutions. Here are my two solutions, right? So if I zoom in on it, because sometimes you can't click on it. If I zoom in on it, the solution's supposed to be this, like negative 39.46, right? I got to see which one of these is going to give me negative 39.46. So if I try answer choice A, that's not it. If I try answer choice B, that's not it. If I try answer choice C here, right, negative square root 39 squared minus C squared, that's not it. And if I try answer choice D, that should be it. Let's check it out. C squared plus 39 squared. Yeah, you see, this gives us negative 39.46, basically like our line is showing us, right? And here you got to know it's okay to plug in numbers, right? The way you kind of know that is, well, a couple of ways. Again, you would have seen similar problems, hopefully, if you've done enough practice, and you'd realize, yeah, here you should plug in numbers. But you're allowed to generally plug in numbers for constants as long as the question is not about the constant. So here, the question is not what is C, so I can just plug in whatever I want for C. And that wraps up module 1, right, in about half that time.
Quick break before module 2. I want to show you something that I built that's directly relevant to what you're watching right now. The way you actually get good at SAT math is reps. When you've done 50 of a question type, the 51st one isn't difficult anymore. It's just obvious. That's what Sigma Prep is. Practice problems organized by topic and difficulty, a video explanation on every single one, instant feedback so you don't keep making the same mistake. But here's the coolest part about it. This exact test, the one I'm speedrunning right now, is on Sigma Prep as a full practice test. Same 2-module adaptive format as the Bluebook, same topic mix, same difficulty curve, but every problem is a fresh variation. So your score actually means something. And every test now comes in 3 unique versions. So when you retake it, you get brand new problems on the same skills. You can't memorize your way to a fake score. So when you're done with this video, head over to sigmaprep.io and take this version of the test yourself. See if you can recall the strategies I'm using here. If you do, you should walk out with an 800, just like I'm about to. And if not, you just need a little bit more practice. When you finish, you get your score and a full breakdown. Every question you missed has a video explanation where I walk through exactly how I'd solve it. And then this is the part that actually moves your score. One click builds you a custom practice set from exactly what you got wrong. You don't have to wonder what to study next. Just do the loop. Take a test, do the practice, get better, retest, see what changed. You can start for free. Your first mock test is free, and so is the diagnostic quiz if you want a 15-minute picture of your weak spots first. If you grind this out, there's no version of you that doesn't improve. sigmaprep.io, link in the description. Now back to module 2.
All right, module 2 jumps straight into it. Open up Desmos. First one says, an airplane descends from an altitude of 9,500 to 5,000 at a constant rate. That's the key phrase here, and they want to know what describes this. That's going to be, well, it's declining, so it's definitely a decrease, and it's linear. Constant rate is a keyword for linear, right? So remember that. Exponential has to do with, like doubling, tripling. Those would be things that are exponential, and also percent increase or decrease, right? So if this said, decrease 10% every minute or whatever, that could be exponential. But here, yeah, constant rate means linear. That's it. Number 1 done. Number 2 gives us an equation. Line K is this equation, 17 over 7x plus 4. Line J is parallel, right? Got to know what that word means. Do I have something there? I don't know if I have it. But anyways, no, I don't have it here, I don't think. But yeah, it's kind of over here and like no solutions. They got to be parallel. Parallel just means like they have the same slope, right? So just 17 over 7, that's the slope. You just got to be able to identify slope basically. Okay, next one here. They give us a function, again, this is a linear function, approximates the volume in fluid ounces of juice Caleb had remaining after making X popsicles. What is the best interpretation of the y-intercept? So we saw this in module 1. Here it is again, right? Module 1, we had to know like the keywords for slope. It was a slope question. Here it's y-intercept, you see. So what do we want to think about our y-intercept? The initial value, the starting point, right? So it's 30. You got to identify the number first so you know not to pick A or B. And then we want something that says like initial or starting, and that's going to be C in that case, right? When he began, right? So that's it. D has the keyword for slope each, right? So that would be wrong. Okay, next one. Physics class is planning an experiment about a toy rocket. The equation gives the estimated height y in feet of the toy rocket x seconds after it's launched into the air. What is the best interpretation of the vertex? We saw a question about vertex in module 1, right? It asked to find like the minimum value, right? So you should already know that you can just type this into Desmos and you should be able to click on the maximum or the minimum, right? So here it is, right? This is our maximum point in this case, right? So we want something that says maximum. They all say it. So it's about getting like the units right. 5.6 was x and x is seconds. So you need something that says 5.6 seconds. So not A, could be B, not C, right? And then also not D, right? You see, that's the only one that has 5.6 seconds. It also has the correct thing for y, the height, right? They say the estimated height, y, in feet. So 502 feet. So just a reading problem, really, right? And knowing you can click on that in Desmos. So over here, we saw also one like this in module 1, you know, where it was a function and we just plugged it in and told it f of 2, I believe it was, right? So here you see, if you type this function in and you ask it to do f of 10, it won't find it right away. Why won't it find it? Because it doesn't know what k is, right? So that means there's got to be something we do in between, right? You got to figure out what k is. So how do you figure out what k is? Well, it's this is the only other piece of information they gave you in the problem, right? You need to understand this function notation. What this is telling you is that if you plug in 5 for x, the result is 32. So you see, the result is 32, so it's going to be 32 equals 4 times 5 plus k times 5 minus 1, right? You can solve this algebraically if you want. If you want Desmos to solve it, just swap out that k, make that x, you see, and then Desmos will solve it. So k is 3. Right now I know k is 3, and you see I just tell Desmos, yeah, k is 3, and then it'll just give me my answer finally because it knows what k is. 67. Next one, triangles A, B, C, and D, E, F are congruent, right? We talked about similar but not congruent, right? Similarity, right? That's probably the more common one. They have the same angles but different lengths of sides, right? So that's why they're similar. Congruent literally means they're exactly the same angles and the same sides, right? So you see, if angle A is 18, angle A corresponds to angle D, right? So angle D would be 18, right? So what about F? Because the question is about F. Well, they also tell you B and E are right angles, right? So, you know, that means it has to be the complement really of 18, right? But you can just subtract those away and you see, you end up with 72. But yeah, just a complement, that's all. Next one here, inequalities. These are freebies, right? Throw this into Desmos. You just kind of write this inequality in, write the other inequality in, and it'll graph, you know, the two inequalities. You want to understand that your solutions, because that's what the question is about, your solutions are in this overlapping region, right? So you want one of these points to be in that region. Just put those points into Desmos. Desmos will plot it. You see, here's the first point. It's in the white region. That's definitely not it. The next one, if I do 0, negative 14, that's just in the blue region. That's not it. If I do 0, 14, now that's just in the green region at the top. That's not it. So it's D, right? You see, D's the only one where it falls in this overlapping shaded region part. So these inequality questions are usually really simple. Next one over here, we got dot plots, right? And it wants to know which of the following statements must be true, right? So there's a couple things here. We have something for statistics, I believe. Yeah, here it is. There's 5 things you got to know for statistics. Here they're asking us about median. Median's the middle number of an ordered list, right? And standard deviation, right? Standard deviation is just really about the spread, how spread out the data are, right? So in this case, right, you could do this in Desmos. I'll show you how. It'll just be a little bit tedious. You want to kind of know these two are symmetrical data sets, right? If you kind of see, if you split it in half, the dot distribution is the same on both sides of 13, right? And same thing over here. So when you have a symmetrical data set, the mean and median are going to be the middle numbers. So I know looking at this, the mean and median are 13. And so that answer is A. It says the median of data set A is equal to the median of data set B. So that's true, right? So it's definitely 1, but it could be 1 and 2, right? Here's how you could do it otherwise, right? So you just understand dot plots better, right? You can also just type in the word median and type in all your numbers, right? So for data set A, you see I type in 10 once, I type in 11 4 times, right? I type in 12 twice, 13 3 times, 14 twice, 15 4 times, right? And then 16 once, right? And you see median's 13 like I told you. And then I can do the same thing for, data set B, right? That's 10 10 and then 11 4 times, right? And then 12 twice, 13 once, 14 twice, 15 4 times, and then 16 twice. And you see same medians, right? And then they're asking you about standard deviation. That's actually something you can do in Desmos as well. It's abbreviated, it's STDEV, STDEV, but they're not gonna be the same. You can tell they have different dot distributions, right? And you can see their standard deviations are different. So yeah, number 2 is not true, so this is 1 only in that case, right? All right, next one. Scientists initially measures 12,000 bacteria in a growth medium. 4 hours later, it measures 24,000 bacteria. The exponential growth, the formula P equals C times 2 to the RT gives the number of bacteria in the growth medium, where R and C are constants. And P is the number of bacteria T hours after the initial measurement. What is the value of R? Okay, so this is not too bad, especially again, if you know about the exponential equation, we talked about it. You see, this is in that form. A number out front represents the initial amount. That's 12,000, right? So like if you write this equation, right? So I'm gonna write it and then we'll fill it in, right? So it's gonna be like this, RT. You see, what do you know? You know that 12,000 is C, right? You should know that. Okay, what else do we know, right? Well, they tell you that it's gonna be 24,000. So that's gonna be the P value. That's like the amount of bacteria, right? They tell that to you there. P is the number of bacteria, right? Okay, and what else, right? Well, R is just a constant, and then T they tell us is hours, right? Well, they tell you 4 hours later, right? So you know the T, right? So in like my exponent, I know T is going to be 4, right? And they're asking me to solve for R, right? And that's how it works, right? You can only have one unknown. So if the question is, what is R, right? I have to know everything else. So the way you can solve this, you see, is just, you wanna try like the different values for R, and you wanna see like when will it equal, when will it equal 24,000? That's basically the question, right? So you see, if I tell it R is 1 over 12,000, answer choice A, right? It'll calculate it. You can plug it in there yourself if you want. But that's only 12,002, that's not 24,000. Then if I try B, that's the correct answer, right? So it's gonna be, R has to be 1/4, right? You could also think about this, it's pretty simple, right? Like if you wanted 24,000, it literally has to be 12,000 times 2, right? Which means the exponent has to be 1, right? Which is why like R has to be 1/4. So that's a question I've seen where they'll ask you about the exponent. Make sure you understand it because it's not always multiple choice, right? Next one, cube has a volume of 474,552 cubic units. What's the surface area? Okay, you do get these formulas, right, in the reference sheet, and they give you volume. They don't give you a cube specifically, right? So I got something for that because it's a common thing. Volume and surface area, the rectangular prism, that's the one they give you. They tell you volume, they don't tell you surface area. So either you have to memorize that or know how to derive it, right? So the formula is just the area of all the surfaces. So you see the bottom's length and width, the bottom and top are the same. So that's why it's 2 length width. The side is width and height. There's 2 sides, so 2 width height, and the front and back length and height, 2 length height. But anyways, then you can take a rectangular prism, and sometimes we'll talk about a square prism. All that means is the base is the same. So instead of thinking about length and width being 2 different units, they're the same unit, call that X, and your formulas as a result. And then cube, here's a cube. Cube just implies all 3 are the same, right? So you see, if they're telling me the volume of a cube, I know it's X cubed. So I can figure out what the side is, right? By just writing in the volume, right? This number equals X cubed, right? And so then zoom out, I can solve it. Sometimes it doesn't let you click on it, right? But zoom in on it, X is 78, right? Now they want the surface area, right? So what was the surface area? Where they go up here? It's just 6 times X squared, right? So it's gonna be 6 times 78 squared, right? We get 36,504, that's it. Next one, another system. This is pretty simple. Just throw this in the Desmos and you can just click on your answers. This one's actually, you can solve this yourself. You see, they kind of eliminate nicely, but I just got to throw it in Desmos anyways, right? I feel like when you kind of like do things in a consistent manner, that's better because then on a test, it's just automatic, right? Whereas sometimes like maybe you could do it by like some combination here, but sometimes you might not be able to, right? Anyways, where do they intersect? Here's where they intersect, and it wants us to do 8 times the x, right? So I'm just going to do 8 times 0 plus, and then it's going to be 7 times the y, right? And we get this. Now, here's a weird thing with Desmos, right? You do not want to enter it in actually as 2.9999. The answer is 3, right? The problem is Desmos doesn't know this is a repeating number, right? I think there's a repeating number. What is this? This is going to be like 4/7. Is that right? No. Yeah, that's not right. 3/7. Yeah, there it is. It's 3/7, right? So Desmos doesn't know that this, you see like a repeating number. So that's why like it kind of doesn't get that. You see, if I add more digits to it, 4, 2, 8, 5, 7, 1, it's eventually going to be 3, right? So Desmos truncates some decimals like this, right? So sometimes if you get an answer like that and you're using their truncated one, you want to know that, you know, it should be 3 and not like enter 2.999, because unfortunately that would be wrong, right? Okay, next one here, conversion problem. A certain area has this many square miles. Keyword square, you got to pick up on that. They'll only do this in module 2, and they want to know square yards, right? So when you do conversions, we have something for unit conversions. There it is, right? You do a lot of this in chemistry. That's probably like where you're more familiar with this than math class, to be honest, right? Otherwise, conversions you do like before algebra 1. Anyways, with conversion, you just got to use your conversion factors, which they always provide you, and just multiply and do your dimensional analysis to make sure your units line up and cancel correctly, right? So in chemistry, it's called stoichiometry. That's probably where you see it. So you see, if I have feet per minute and I want to get rid of feet, right, I have to put feet on the bottom so they cancel out, right? So the only weird thing about this one is it says that it's square miles. You got to pay attention to this, right? I'll show you the trap if you don't catch this. That means it's like 4.36 miles squared, right? So then you see, if I multiply by the conversion factor, if I put 1760 yards over 1 mile like this, right, that's not going to give me the correct answer because this was square miles, right? And it's not going to cancel with just mile, right? But you see, they probably have a trap answer waiting for you if you make this mistake. Let me go ahead and show you. Yeah, you see B would be waiting for you. How do you fix this? Well, if it's square miles, all you would have to do is this. Take that conversion factor and square it, right? So over here, I just wrapped this in parentheses, squared, and we get this answer, which is answer choice D then, right? So that's it for number 12. Number 13 here gives us triangles, right? And it gives us the vertices, right? So here's a cool thing. You can actually do this in Desmos, right? You can put in a point and you can even label it, right? I can give it a name like this, R. There's point R. And then I can put in the next point, 4, 7, right? And that's going to be, sorry, that was P. I forgot the order. P, and then this is Q. And last one, 6, 5. This is going to be R, right? There's our triangle. It's going to make like a right triangle if you can picture that, right? I can't really connect those lines in Desmos to draw the picture, but anyways, that's it. Then they tell us L, M, and N, right? So we can have more points to plug in. 4, 5. That's going to be L, right? And then it's going to be 4, and then it's going to be 7 plus K, right? And that's going to be, so it's not going to draw this because it doesn't know what K is yet, right? So I'm going to just tell it here. Let's make up a number for K again. K is 3. And then the final one, now I can label that. That was M. And then finally 6 plus K, 5, right? And this is going to be N. So this is an annoying problem because you have to draw it. So you probably honestly want to draw this on your paper. I think it would be quicker, right? But anyways, what you're supposed to see is this going to be similar triangles again. When you have like this small triangle, you see if you connected and drew these lines, you'd see that you have this small triangle inside this big triangle. Those are always similar triangles, right? So I will draw this actually out here just so we can kind of see that, right? Let me go back to my drawing board and just kind of draw this out quickly, right? So you have, you know, this small triangle, right? And then we have the big triangle. All right, and let me just connect this. There we go. Okay, so in the small triangle is like this. It was P, Q, R, right? And then in the big triangle, it was L, M, N. So like this. And so, yeah, final thing then, right? What do they talk about? You know, basically it was just seeing that. So it tells us that angle Q is T, and they want to know what is angle N. So you see over here, if I put in T degrees over here, right? Then, because they're similar, you'd also have t degrees over here. And then you also know that these are right angles because it was a vertical and it was a vertical and horizontal line here, right? So they're perpendicular. So the question is, what's n? So basically what you want to know is like these acute angles, these angles are acute. They got to add up to 90, right? We talked about this earlier. I was doing one that was a complement. It was the same thing, right? So how do I express this over here, right? Well, if they got to be complements, right, then that's going to be just 90, right, minus t, right? So they got to add up to 90, and this one's t, so that's it. So that's the answer we got to look for, 90 minus t. That's it. Okay, weird kind of question, and honestly, just a pain. Time. It takes up a lot of time just because you got to draw it. Anyways, 14. A business owner budgets $2,200 for candles. The owner must purchase a minimum of 200 candles to maintain discounted pricing. If the owner pays $4.90 for small candles, $11.60 for a large candle, what's the maximum number of large candles? Okay, all you got to do here is just make a system because you have large and small, right? So we'll do 490x plus 1160y. This has to be less than or equal to 2,200. It's inequalities technically, right? We got a budget. It means that's the maximum. We can't go over that. And then we also need a minimum of 200 candles, which means x plus y is going to have to be greater than or equal to 200. And we saw inequalities before, so anything in this overlapping region, right, is going to be a good answer for us. They want to know what's the maximum for the large candles, right? And large was y, right? So we want to find like, yeah, this is the biggest point, 182. You can't have 183, right? You see this 182.08, so 182 is going to be the maximum. You can verify that if you do 490 times 18 small candles plus 1160 times 182 large candles, it's just under that budget, and then we'd have 200 candles, right? So that's it, 182. Next one here. A square is inscribed in a circle. The radius of a circle is square root 20 or 20 square root 2 over 2 inches. What's the side length of the square? So yeah, let's draw this out. It says a square inside of a circle, right? So draw your circle first, and then we can draw our square, right? So yeah, you'd want scrap paper to sketch this out. And then they tell us the radius, right? So the radius would be just like half of it there, right? You want to draw it to the corner, right? That's the relationship. You can draw it up here. That doesn't help you. But what you really want to see then the diameter is the diagonal, right? So that's kind of what we want to know. Diameter is the diagonal. And so we know the radius is, it was this, what was it? It was 20 square root 2 over 2. So if you double that, right, this is the diagonal then, right? 20 square root 2 is going to be like our diameter, because if you multiply that by 2, just cancel the 2 in the denominator. The question is, what's the side of the square, right? So a couple ways you could do this, right? So here again, we know this is 20 square root 2. All right, and so then the two ways that you could do this is you can just do Pythagorean theorem. This is a square, you know, so these sides are the same. So you see, I can just do this in Desmos. X squared plus x squared equals this squared. So I'll show you that. So it'll be like this, x squared plus x squared. And Desmos will just, you know, do Pythagorean theorem for you, right? So it's, sorry, it was 20 square root 2 and then squared, right? So then I could just click on it and you see I get 20. The other way you could do it is this. It's a 45, 45, 90 triangle because it's a square. So if that was 20 square root 2, you see then the sides are just 20. So whatever way, both those are fine. Next one here, simple one, you can just put these in Desmos. If you put this in Desmos, Desmos will draw it, right? And then you can just kind of see like which one's the correct one based on like what they're saying, right? So here I draw this circle and I zoom in on it. It's saying that it should touch the y-axis at exactly 1 point. This is not touching the y-axis at all, right? So that's not it. B is the same equation basically, just change this to a 4. That touches the x-axis, that's not what we want. Next one, it's x minus 4 and y minus 9. There you go, this one touches the y-axis at one place, and you see if I change it to D just to eliminate that one, that would be 2 places, right? So that's it. Next one, 17, gives us an equation. It says it's one of 2 equations in a system, and the system has no solution. We did this earlier, right? We talked about this earlier as well. No solution just has to be parallel. So that means this line and one of these has to be parallel. So just put that into Desmos. I think that's the simplest way, right? You can just check, like if I put this in, are these parallel lines? No, these are the same line. That would be the answer you want if it said infinitely many solutions, which they definitely could ask you, right? Next one over here, put in B equals 22. That's it, they're parallel, right? So boom. Next one, which expression is equivalent? So I told you that there could be another equivalent one. This one you would want to do in Desmos. You see, this would be nasty to just kind of like, you know, do the algebra for it, so don't do that. It's going to be time consuming, and you see, that's the thing, you know, if you don't know the most efficient ways to do things, you could definitely run out of time in this section, right? But here's how you do this in a really, really efficient way, right? X squared y minus 8xy. Desmos won't draw this because when it sees x and y, it wants an equation. So just make it an equation, make it equal like a number, like 4 here, you see, and then I see a graph. Now, because this word equivalent, right? Equivalent just means like one of these answer choices must be the same as this. I just put these answer choices in, also equal them to 4, and one of them will be the same, right? And that's how you do this in like probably a much faster way than if you were gonna attempt this with algebra, right? So plus 64xy, right? And then equals 4, you see, that's not the same thing at all, right? So then that's just not it, right? And then what I would look at is see if any of them have the same denominator. You see this one has the same denominator, so I would try D next. That way I don't have to rewrite the whole denominator. Xy squared plus 13xy minus 8y, right? What does this graph look like? Yeah, that's not the same thing either, right? So it's not that. So it's got to be one of these two, right? So I'll go with B, and so that's xy plus 9y plus 12 over x squared y minus 8xy plus x minus 8. That's not the same, so it should be, let's check it out, it should be C, but yeah, I would enter it in just to make sure, because it could go wrong if you type the original thing in wrong. Hopefully you don't do that, right? So xy squared plus 13xy minus 8y, let's see. There it is. You see they're exactly the same. If I turn off this green graph, there's the blue one underneath it, right? So yeah, unfortunately I had to try all of them to realize it was C, but yeah, still going to be a lot better than doing it with algebra. Same thing here, right? You can do almost the same thing here. This is an equation. We want to see which one of these are basically going to be, you see again, equivalent, right? So here's what you could do if you put this in. 20 over P equals 20 over Q minus 20 over R minus 20 over S. Again, Desmos won't draw this because it doesn't know what these things are. Here's how you get Desmos to give you a picture. You change two of them to be X and Y. It doesn't matter which ones, right? I'll change, you know, these two to be X and Y, my P and Q. And then for R and S, I'm just going to give them numbers again. Let's say R is 2, S is 3. You know, we get some numbers. And there's your graph now, right? Now that Desmos has it, you see this first line has this purple color, it graphed it. Now one of these have to be the same and it has to be equivalent to Q. What that means is it means like it's saying this thing equals Q, right? So my Q is X. So I'm going to write like you see X equals, and then P was Y. So it's going to be Y plus R plus S. That's not the same graph. Next one, X equals 20, and then it's P plus Y plus R plus S, right? So that's also not it. So it's not these two, right? So it's got to be one of these C or D. So next one, it's Y, which was P, which was Y, sorry, and then RS, and then down here, PR, so that's going to be YR plus YS plus RS, right? And again, have to make it equal to Q. Desmos use the same color here, which is annoying, right? So let me, oh man, that's so annoying when they do that. Let me re-enter that so we can see it as a different color, but that's the correct answer, right? YS plus RS equals X. You see black color now, okay? And then you can see I can turn that off and it's the same color. Desmos use purple again, I don't know why, but you know, now they match, right? So if you know that, and you know that you should do that once you kind of read it, you know, those last two equivalent ones are really easy. Next one here, this one, quadratic, right? This is gonna be a quadratic. You need to use the discriminant for this, right? So I'm gonna explain how I know this should be a discriminant one, right? The discriminant, you need a quadratic, that's one. That's actually a tricky thing here. And then they'll always tell you that whether you have two solutions, one solution, or no solution. So we got to enter one of these in. And here it is. It tells us there's no solution, and it's always finding an unknown. So this doesn't look like a quadratic right off the bat, but if you distribute your x, right, it's kx squared minus 56x. And then if I move the negative 16 to the other side, this is it. You want to do that because you want to identify your A, B, and C, right? And then you want to plug it into one of these, right? So here we're using this one because it said no real solution, right? We're going to do b squared minus 4ac and set it less than 0. And again, if you know how to do this, it's not too bad and it goes pretty quick, right? So put your parentheses around your b, a, and c less than 0. Last change you got to make, again, the unknown has to be x for Desmos to find it. You see, I put that, I zoom out. Anything in the shaded region, so anything bigger than 49, is going to be the value of k that has no solution. They want to know what's the least number it could be. So it's the smallest number bigger than 49. Can't be 49. You see there's a dashed line passing through. That's why the answer is 50 here. Okay. Next one here, this one's pretty simple too. If you've kind of seen something like this before, if this is the first time seeing it, you probably won't get it, but it's actually ridiculously easy. If you put these two into Desmos, you'll see that it's actually the same line, right? You see same exact line. And then they're just literally saying one of these points lies on the graph. So all you got to do is just put these points into Desmos, right? And see which one is going to be on the graph, right? So we're going to encounter an issue again, right? And it's that it's not going to show us anything because it doesn't know what R is, right? But here again is the situation, just like we saw question 22 in module 1. Someplace you got to know that it's okay for you to tell Desmos what a number is, right? So here I'm going to tell Desmos R is 2, right? And if R is 2, you see this point is not on the line, right? So that's not the correct one. So then I just go and try B, negative 3R over 2 plus 7 over 2, comma, R, right? And that one is on the line. And you see, even if I change the value of R, this one's always on the line, right? And that's it. It's actually literally that simple, right? Last one here, classic problem, right? You got to pick out your linear equation, right? If you just read this, most people, if you read this and you don't do any math, you're going to get this wrong, right? But I'll show you two simple ways you can do it. It tells you window repair specialist charges $220 for the first 2 hours of repair. And an hourly fee for each additional hour. The total cost for 5 hours is $400. What function gives the cost, right? So people will just read this and they'll probably pick one of these two because of the 220, right? But those are going to be wrong answers. So the easiest way to do this again is just get Desmos to tell you what the equation is. Open up a table and do a regression, right? These are linear functions, right? You want to notice they're linear. You just need 2 points. They give you 2 points. You just have to be able to read, right? X represents hours, and then the Y is the total cost, right? So if you want points, they do give you 2 points here, right? Here's the first point, 220 for 2 hours. That means X is 2, Y is 220. And here it's even clearer, 5 hours, X is 5, and Y is 400. Hit that, do the regression, you get your equation 60X plus 100, right? You don't fall for their trap. Again, this is a very common module 2, end of module 2 question, right? So if you know these, that's it, right? So that's it for module 2. Not too bad. A lot of very things you should always expect, right? And again, things we have practice on Sigma Prep for, right? If you do enough practice, again, you should be able to recognize like 95% of the questions on a test, right? So that's it for module 2. Let's submit that and let's go check out the score. Should be another perfect 800. So let's take a look. So view your score. And there it is, perfect 800. That's the full set. Every Bluebook practice test, everyone a perfect 800, all on this channel. If you're chasing your own 800, all of these tests are waiting at sigmaprep.io. 3 versions of each, fresh problems every retake, and it builds your practice from whatever you miss. Like and subscribe, a lot more is coming. Stay tuned.